Okay, so we will get started. Welcome everyone. Thank you so much for joining us today. We're excited to be here with you. As part of our webinar series, today we're introducing our new Aeration design calculator tool, and I am sure that it will quickly become a favorite of yours. My name is Lina Chavarini, and I have been with SSI for 17 years. I'm here to help present the module. With us is Kiran Nim Kumar. He's joining us as well, and he has led this effort with the engineering team for the design and the development of this design calculator. We're really excited to share this with you today, to introduce you to this software. It will be a very valuable tool for you. Let's see some chat. Welcome everyone in the chat. A lot of our panelists are there, Tom, all the team, Jason, Doreen, so feel free to say hello and to ask any questions that you might have. Some of them we might answer live as we explain the tool and what it does. So why use the SSI design calculator? Basically, it's flexibility, speed, and is to give our clients another advantage about working with SSI. Hold on one second. I see somebody raise their hand. Bear with me. Okay, it was already addressed. So why use the design calculator, or what it is? We will explain that momentarily. But SSI is known for providing or empowering our clients base for flexibility. And this tool is designed to help you make budgetary proposals, quick calculations, and give you a quick, easy access to our know-how, to our design parameters, and offer that flexibility of providing and working on quick diffused aeration system calculator, technical proposal, and commercial proposal. So with just a few clicks on our software, you can generate a full technical design that includes calculation sheets with airflow rate, discharge pressure, SOT, all the key parameters that you need, and also a single line drawing, as well as a budgetary proposal. It will save you time. It will allow you to respond to your clients quickly. It will allow you to play with the different configurations that we offer. The key here is flexibility. It is convenience, because the software is going to be in the cloud, easily accessible from everywhere. You can save your designs. You will be able to access them, modify them, and play with the different parameters that it has so that it matches your project's objectives. One disclaimer is that it's not meant to replace SSI's technical assistance and SSI's technical assistant and SSI experience or know-how. Is just another tool, another resource that we're providing our client base, and that it's an advantage about working with SSI. We consider ourselves very open and transparent with our clients, flexible, and this module or this software shows that. So again, not meant to replace our technical assistance. We're here to support you. This is another tool that can empower you and that can provide quick access to designs and technical proposals. We will explain in detail. We will do a live demo, and we will log in together, and we will go over all the key features of the software. But you can It considers industry standards for the different aeration processes and applications. Something that is very interesting is that you will be able to compare different type of diffusers depending on the project objectives, whether it's operational efficiency or capital expenditure. You can select that. This software took over 5 years if you consider all the modules that are behind it on the back end to integrate. So a lot of engineering hours have gone into it. It has been a labor of love, and we're really, really excited to share that with you. Bear with me. So here we are. This is the first step, is how do you log in, or where can you find it? We're going to go step by step. So you can find the design software on design.ssiaeration.com. On the chat, my colleagues are going to copy that for you to make it accessible. So let's see. We're going to go to the website. Bear with me. Can you see the screen with the design.ssiaeration.com? Can you guys see my screen? Okay, perfect. So the first step is, okay, how do I get credentials? If I'm a new user, how do I get access? There's 2 ways for you to get access. One is you can go to design.ssiaeration.com, and if you don't have an account, you can hit sign up now to create your own credentials and password that will give you access. And the other way is to ask for SSI to give you an invitation, to send you an invitation. So you will get an email from us with instructions on how to get access. Typically, the process can take up to 24 hours, depending on how many requests we have. It's pretty quickly. We're working on optimizing it so that you have fast and easy access. If you, for any reason, don't see an email from SSI with the instructions, please check your junk folder, because it is possible that the email goes there. So please check your junk folder, or contact us if you're having any technical difficulties trying to establish your credentials or trying to log in. We will work with you to get that solved and to get you into the software as fast as possible. So I'm going to log in here with my credentials. I'm going to log in as a user. Bear with me, it's taking a little bit. There you go. So this is, once you're in, once you have credentials and get access, this is what you're going to see. This is the main page that will allow you to start your own designs and to create your proposals and single line drawings and calculation sheets. I'm going to give a little bit of an overview, and then my colleague Neem will give examples for different processes, practical examples that will give you an idea of how powerful this tool is and what it can do for you. Because SSI is an international company and we have clients and offices worldwide, it is important for us to offer a tool with as much flexibility as possible. So the tool is going to be available in different languages. On the top corner, on the top right corner, you will be able to select the language. For now, it's available in English, Spanish, Chinese, French, and Italian. So you can select the language that you want to see the language in and the outputs. The first step that you're going to do is you're going to name your project depending on the wastewater treatment plant project name, and you have the flexibility of select the units, US, obviously, and metric for the rest of the world. Type of inputs, you have also the flexibility of selecting your inlet parameters. If you have BOD, that will be defining parameter. If you have AOR or SOR, you can do that. Process type, this is very important because we have the capacity of adjusting the aeration design depending on the process. AST is activated sludge treatment. So this is the conventional activated sludge. Then you can also adapt it for the other processes such as MBBR, SBR, MBR, post-aeration, channel aeration, digester, sludge holding tank, and EQ tank. And they are going to account whether it's for a process that requires dissolved oxygen or mixing application. So it will adjust the industry parameters that are used for depending on the process. My colleague Neem will go over some examples later that will explain, okay, if it's a digester, how do I do a EQ tank design, depending if it's only for mixing, for example. So it will, if it's for mixing, it will show you the design standard in terms of airflow rate per square meter, for example. So you have the process type selection and the design standard for the aeration needed depending on the process. Tank type, you can choose if it's a rectangular tank, circular tank, or other type of tank. Diffuser type, we have a wide range of products, and here you can select whether if it's fine bubble diffuser, disc, tubes, or coarse bubble. Nim will also explain later in an example how you can compare different type of diffusers, because that's a frequently asked question. When do I use discs? When do I use tubes? For a digester, what is the comparison for, if I go with fine bubble diffusers versus coarse bubble diffusers? So in this, a little bit later, we will explain how you can do that comparison by diffuser. For example, here, so here you have the ability to select the diffuser type. 1 millimeter slit is our standard diffuser. 2 millimeter slit refers to the size of the slits, and the diffusers, the 2 millimeter slits, give you a little bit greater capacity in terms of airflow range, and also a little bit of larger bubbles. So when you need a little bit more mixing, the 2 millimeter slits is an optimal selection. It can also help you mitigate fouling in aggressive industrial applications, etc. So, and then the comparison. This is one of the last things that I'm going to be explaining, is you can do comparison depending on conditions. So you can add here a condition, and you can name this, for example, maximum flow. And this one can be a design flow or minimum flow, or it can be summer versus winter. You can compare, or you can do the calculation depending on different conditions. Then if you don't want that, you can simply delete that comparison and start a new selection. Then by zone, when you have different trains and you have taper aeration and you have different densities or different configuration depending on the zone, then you have the flexibility of modify or add different trains, different zones. And finally, this is my favorite, the diffuser comparison. Here, you're able to compare different selections. For example, I want to compare 9-inch discs with 12-inch discs and with tubes, because I want to know what will be my airflow rate. I want to know what will be my SOT. I want to know what's my operating conditions and the cost. So that's one of my favorite comparisons. I have to mention that SSI is probably the only company that has that, and primarily for international projects, that is a very important analysis, the comparison between the different type of diffusers in terms of project objectives. For example, let me say this, the default parameter or design basis for the analysis, for the calculation, is based on OPEX, or operating efficiency, so highest efficiency. In the US, when consultant engineers are making their calculations, this is the most important selection. However, for other projects, depending on the budget, depending on the objectives, projects overseas, maybe if it's an EPC and they are looking for the most economical option in terms of capital expenditure, then you can select CapEx for your evaluation. So there are two different options. The default is based on efficiency, as we pride ourselves, or we always try to bring you very efficient aeration systems. However, you can also do that comparison depending on the lowest capital expenditure or highest operational expenditure. The outputs unit, this is important depending on if it's metric. If you select metrics, then you have the option of having the outputs in the standard meter cube per hour or in normal meter cube per hour. So you have that flexibility, or both. So that's basically it. If you select if you select tube diffusers, for example, then you have the option of selecting pieces and sets. And I'm going to have my colleague Neem join us to walk us through different examples depending on application, practical examples, for you to see what the calculation is, what the once you calculate, depending on the inputs, like the flexibility that you have to calculate and to see the outputs. Nim?
Helena, thank you.
Hi.
Thanks for your support and thanks for your nice explanation. Hey guys, this is Nim, Kiran Kumar Nim. I'm with SSI from past 15 years as a engineering support, backend process and engineering support, having 15 people of team. So after having a past 15 years experience with dealing with the different uh, market, different area people, we have made this application to user friendly for flexibility to work, to make clients their own designs. So basically we uh, incorporated uh, all applications and all process types and different kind of outputs what people clients can expect based on the consulting engineer requirements and based on the client requirements to give OPEX solution as well as CapEx solution, like to provide any kind of solution in a single platform so that people don't go different pages and ask different questions, and they can get single output at the same web portal. So here, as Lina already explained, I don't want to repeat everything again. So these things are already covered. So just want to show you how this application will work. Basically, the comparison type is very important, which we put a lot of efforts to meet different zone people. So here, if we select condition, it takes like a comparison of design with the same diffuser model having a different condition like minimum, average, maximum, peak flows, and daily flows, minimum conditions like that. So I'm just filling the information like minimum, adding 3 conditions. So here there is an option of autocomplete. If there are multiple conditions to be filled, we can select this option as a S, so that we no need to fill again for each column. That saves a lot of time. So minimum flow for this project, say like now it is different flow. I am filling 9,000 and peak flow as a 16,000. Again, tank dimensions will be same. So I'm just click again autocomplete to S. So making design here, quick view option is also there. So we made this application to not to waste time. So whoever have technical knowledge, they can see different all design parameters contains in the overall the calculation. But also we kept quick mode option, so people can see only important requirement input versus output based on the level of project analyzation. The sales people doesn't want this technical, then technical, and when it comes to technical analyzation, people can go to quick mode and they can see all other information, all technical parameters incorporated in the design. So now we can adjust diffuser for a 9-inch, taking an optimal flow range as an average condition. We are changing to 1400 pieces. Automatical other columns also adjusted to 1400. So giving the minimum condition, average condition, and peak condition. So we'll get same diffuser density with the different sort percentages. This sort also based on the ACE standards, what we conducted number of plenty of sort tests for all over the world. We collected all those test results and we made a Corrosion software, and this design calculator will be um, linked to Corrosion, and those sorts will be automatically can reciprocate here. So even you can see the Corrosion right away in the same design Aeration portal instead of not going Corrosion link as which we shared to the clients 2 years back. So no need to fill here any information. Automatically whatever the data we entered in the earlier page, it take a diffuser model, diffuser submergence and density. You can get two result of sorts like percentage per meter or specific oxygen transfer. So you can get both design as well as curves in the same page.
Nim, oh,
Yeah.
there, I think in the curve, it will be good to mention like that it shows the design range. So it is very self-explanatory to
Yeah.
tell our clients where it falls within the recommended or intended airflow range and when it's outside.
Yeah,
So it,
basically each diffuser have its own operating flow range and as well as design flow range.
mhm.
The level of like this red color range is operating flow range, which for continuous operation, but diffuser may go up to flow range when there is a peak hour flow rate, which rarely we meet that condition. So for designing the diffuser quantity, this design calculator will take in between the range of design flow range, and if it is uh, crossing the flow range, then alert will come. If we are giving diffuser quantity less than operating flow range, it will alert. Here 6 meter cube per hour we kept as a maximum flow range for 9-inch diffusers. When airflow per diffuser increased more than 6 meter cube per hour, this automatically alert that this design is over designed for taking like peak loads.
That is really important because it is intuitive and easy to use in the sense that it will give you alerts when it is something is outside the parameters, outside the design parameters, so that you can adjust and correct so that
Yeah.
your design is sound.
Yeah, both in minimum and maximum, it will alert in red color rectangle so that the design is under limited, under designed or over designed. Like diffuser quantity is not in the limit to select the different conditions. So after every design, it is must and should to save it with naming like then we can get output in PDF format, only technical design with curves and without curves in PDF format. So here, like this design number or document number is very much important. The client can again retrieve anytime if any revision is required or if someone want to change the information to the existing data, so they can keep this information in the design number. They can retrieve back their design and they can update anytime. And n number of revisions can be done in the same document number. So we kept in the output for PDF with first page as basic information input versus output. As we kept in UI, we also kept the same thing in output also. The if anyone technical person has to review the second page onwards, it give all data related alpha, beta, theta, and dissolved oxygen information, site saturation, oxygen saturation values. Everything will be visible in the second page onwards, and they can print with the curve or without curve, because some if there is number of conditions, printing the curves along with the design gives number of pages. Instead of giving that file size to reduce, we have given option with curve and without curve. And here the main important thing is a commercial offer. This diffuser design, you will get technical proposal, whereas in the same portal we kept commercial offer also. You can see we have kept many options based on understanding the different clients and different informations we got from past years. We kept different information to get their outputs in commercial way also. Like there is a drop down menu we kept, they can select with drop pipe or without drop pipe. So here there is 150 mm above water level keeps as a standard proposal from SSI, 6 inch above the water level. If they don't want drop pipe, they can select 1 meter above the tank floor. That means only PVC part from manifold and headers. And the third option we kept as shown in the drawings. If we have any engineering plans and the termination point from contractor to supplier, we can give this information here based on the drawings. And we also gave different flexibility options, like to select the piping type also. Standard proposal contains for fine bubble 3 or 4 SS drop pipe and PVC manifold and PVC headers. So we kept that also by seeing different requirements from overseas projects. We kept 3 or 4 as a base option, 316 is there. And if people want all material in 3 or 4, we can give like 3 or 4 drop pipe, manifold, headers, and 316 all piping in 316 also. And here we also giving drawing, single line drawing. They can see here drawing with limited dimensions, still progressing with plenty of information can get in future phase. Then here download option to get the output. For that also, after seeing number of requirements from the clients, we selected here to give the output price in different currency. Like basic by default we kept United States dollars, and we can also download it is in euros, INRs, and we are still working to give different Canadian dollars and other country um, currency also. For output document, we also kept now for the time being English version and Italian version is done, and we are working on French and Spanish and Chinese languages also. Here to download the output, so technical design output will come in PDF format, and commercial proposal output is coming in Word format. The format and look-wise presentation is same, which we are continuing from past years. This document quotation file will be the same format. It contains again the technical information of design, airflows, and diffuser quantity as a first page. Then commercial offer, including scope of supply, table format of material, and single line drawing here in a space, and you can get total lump sum price at the bottom, and including the terms and conditions and general information as well as payment terms, etc. So this is about like all options, like bottom downloading the PDF and document will be the same. So I don't want to repeat again for that, but I want to explain the options of flexibility in the design stage. Like now I explained condition wise for a if same application having minimum, average, maximum conditions I have explained. Now we'll go for zones. For example, if we have
Nim,
uh, yeah,
Nim,
Nima,
can we do that in US units?
which one?
Can we do that example in the US unit so that
Yeah, of
they see?
course.
I have some questions on the chat that they would like to see
Yeah,
the option for US
I
units.
kept like 5 examples, three in metric and two in US. Okay, I can do that in US also, not a big deal. So here I'm selecting. Let me refresh. Condition with Jones. So here, this button plus button will give you adding Jones at the bottom. Like if we have two trains or three trains in the same aeration tank, and in between you can add zones also by adding this number of conditions. Now when we select comparison type as a zone, this complete platform will change as a zone wise. That means each column diffusers will be different as a tapering aeration. Zone 1 will be the different quantity, zone 2 will be the different quantity of diffusers. So to make tapering aeration, we can compare here adjacent to adjacent. If it is a condition, we can compare adjacent to adjacent column wise. We can add number of columns up to 15 columns. I'm filling information in S4 pounds per day. when you add number of trains or zones, so this calculate button will come from bottom to individual zone wise, so that there won't be any difficulties. If you click calculate, no other columns will affect to refresh the column. So that's why we kept calculate button here. Every time this calculate button will only affect to the particular train or particular zone only. So this option we kept because of, instead of filling number of pages or number of documents, we can fill in a single page and we can get the output in a single page output with the curves and without curves, all sort information, all design information in the same page. So let us download a output. Here's here you go about different, each aeration tank have a number of trains and number of zones. You can get the output in a single page. So after saving design, how we can retrieve the old design. For example, now I'm refreshing the page. Existing project design number was like 3319. You can see here your project, either with project name or document number, you can retrieve it back, and you can change any inputs you want to. After later revision stage, you can update the design and you can save as a version 2. Now I'm changing the tank dimension here to 30 and saving as a revision. Now you can see revision 2 here, and you can retrieve both the earlier version and revised version also with the same uh, document number or design number. So now design number of 3319 have two versions, one with existing, and version 2 is the updated version which I changed the dimensions. Bear with us because design is having number of conditions and columns. It's taking little more time. Here's the design which I changed 30 feet zone length. So that has been saved as a revision. So going through other flexibility here, we can compare diffuser type also in the same platform. Earlier I explained condition wise to compare same design condition in different columns, minimum, average, maximum, and I also shown how to fill a number of zones, different zones in the same page. Now this is the very important, and we can compare two different kind of diffusers in the same application. So I'm selecting base option as a 9-inch and other option as a optional with tubes for the same inputs or same design parameters having 400 pounds per hour of SOR with the same dimensions of tank. So yeah, to maintaining same density of both diffuser models. More or less 5% density for 9-inch and tube diffusers. The sort is different because always disc diffusers have better performance than tubes. We can use discs as OPEX solutions and tubes as CAPEX solutions. See the difference for the same density. Sort is the 2% per feet for 9-inch option and 1.59% per feet for tubes option. And here, while going with the 9-inch option, annual operating cost is less than tubes. It is like 36,639 US dollars. Whereas if we select tubes, we're having less sort, the operating cost is higher than disk. Whereas the comparison purpose, disks will give you operating cost less than, even though it is initial equipment cost is a little bit higher than tubes, and tubes can be considered for uh, economical option while initial capital expenditure of the equipment, but it costs more for operating long run. So here proposal also you can generate both in the same page for 9-inch and tubes. As I explained already, the supply limit and piping time type can be selected for each case differently. This is the disk diffuser design, and you can download 9-inch option proposal here. And whereas you can see tube diffuser proposal and drawing in the same page. So is the output of tubes option having cost of $20,253, whereas if we see 9-inch option, 29,000. That means cost-wise, 9-inch option is higher than tubes, whereas efficiency-wise, 9-inch is better than tubes. So this is like to explain comparison purpose diffuser. So we also kept as much as possible process types here. AST means activator slash treatment, which Lina already mentioned. MBBR, we are also preparing a parallel software with the start to end of MBBR process, so that this design part will be incorporated in MBBR software. Then as where only some of inputs will change, like for MBBR, DO will be by default 3 and alpha will be little higher than other process. SBR will be different based on the aeration time, like 12 hours or 16 hours based on the cycle times. And MBR will be based on it contains always more solids. The alpha will be lesser than other process. So rest here are like we also calculated based on industry standards. We made post aeration, channel aeration, and digester, sludge holding tank, equalization, or homogenization tank. Post aeration, when we select post aeration, it goes automatically. Type of inputs will be changed, like it requires always input DO as well as flows, and AOR or SOR. Sometimes if nothing inputs are available to get the DO, we can provide with mixing application also. And same way, channel aeration, normally industry standards follows like 5 SAFM for linear feet uh, based on the channel length. And digester is like to keep solids in suspension, and sometimes to treat some odor control and some oxygen loadings. we made some all we incorporated as much of as possible options so that customer can play with it. And if have any questions, we are always here to support as usual, like how SSI is known to better in technical support always. So we are always, the team is always ready to support. But this our application we made for make client easy access, and they can get in fingertips, like making some ballpark budgetary numbers or design parameters which they can get within a fraction of minutes. So here for digester, we also kept like based on the suspended solids percent, like MLSS level in 10,000 to 15,000, we kept it as a 1% to 1.5, 1.5 to 2.5. Maximum we can treat with only aeration system up to 3.5% solids. When you change this solids percentage, design criteria also change. And before I forget, please make sure that this code is based the iterations will start from the left column onwards. So when you have made any mistakes, please always delete from the right side of the columns only. If you delete the left side column, the code will be disturbed and you won't get proper result out of that. So design standard, it is showing like when for solids 1.5 to 2.5, by default it has 40 SFM per 1000 cubic feet. Let me show one example for equalization tank with mixing also. For equalization, we kept another option of BOD removal, because sometimes if there are industrial application or leachate application, the plant have huge BOD loading, which they want pre-treatment. Sometimes in equalization also, that we can calculate as a BOD removal from some up to 10% to 20% of removal in equalization tanks. That's why we kept BOD removal. And if customer have some oxygen loading in terms of AOR, SOR, we can select that. And normal equalization tank used for mixing purpose to keep solids in suspension before going to the aeration tank, not to settle solids on the bottom. So I'm selecting coarse bubble application for equalization tank. You can go again, design criteria, mixing application area wise and volume wise. If it is area wise, the formula will be 3.67 meter cube per hour meter square. If it is volume wise, it's like 1.2 meter cube per hour per meter cube of tank volume. I want to show, already I have shown rectangular type. Let us go circular option also. Circular tank in diameter, 8 meter diameter and 6 meter depth. If you have noticed, for regular other fine bubble diffusers as well as reliable coarse bubble, by default piping type is 304 PVC and PVC. If we select our wideband, coarse band diffusers in SS, the complete piping will be in SS. When we select wideband option, automatically piping type also change to 304 complete in SS material. I'll show in the next example. Here, this is the reliable option with equalization tank for coarse bubble using circular. And we also kept one more option if there is like we don't have rectangular or circular dimensions. We kept other to consider as an area. So you can fill only area here. Instead of inputs in the input type, it won't ask length and width or diameter. It directly asks for area. You can fill meter square or feet square in while using imperial units. And finally, I'll show sludge holding tank with wide bands, because if we continue this way, it won't be the time will not sufficient to explain in detail. So will provide in detail training or other sessions. Whoever interested to understand this step by step, or we can share this video after completing this meeting, so people can come back to us, so that if they want special training or detailed information, we are pleased to help you.
Nim, on that note, I just wanted to tell everyone that I believe next week, June 7th, I believe we will be doing this session in Spanish. I see
Okay.
a lot of people here from Latin America, so we will be doing the training in Spanish as well for those who are interested.
So this is the final last example I want to explain, so that we have covered everything. So as I said before, if we select for coarse band application, by default it will change 304 SS and all piping. So lot of areas we covered, like wherever things will change based on the other information, like alpha will change based on the mixed liquor suspended solids. So that is already we kept in between code. Automatically, if we change MLSS, alpha will change. And the same way we kept elevation versus barometric pressure. So people could not bother about that, whether they are entering they need to go again, search about alpha value, search about barometric pressure, etc. So this is wideband option. So you can download in any language, like already I shown in English. Now I'm selecting Italian, and I'm selecting in euros. So you can see language translated in Italian language, as well prices are in euros. Sorry about this image quality on wideband application. We are working on it. In coming few days, it will be sorted out. Hope I have explained to understand somewhat. If people have any questions, I am pleased to help you separately also. Thanks for your give time for providing us to your valuable time to get knowledge about SSI design calculator. Thanks, Lina. Can you take over?
Thank you, Nim. I think that concludes the overview and the overview of the software. Now is the time for you to ask any questions that you may have. We will be happy to assist you. If you want to raise your hand, or if you want to type them on the chat, we will read them and we will answer it. As I was saying before, we will have a session in Spanish just to explain everything better for the Latin American audience. And we plan to do one-on-one training sessions as well. If you want to contact us, if you want your technical department, if you want to share it with your colleagues inside your company, we will be more than happy to plan and schedule those one-on-one training sessions. Or if you should already have an invitation or be able to create your credentials. So those of you who register while we were on the webinar, you should have access already. Please contact us if you have any technical difficulties, or if you are unsure if you're working on a proposal or on a design and you're unsure about certain parameters, what to consider. Any questions that you may have, just refer to the document or send us a copy of the design calculation that you're working on, and we will be more than happy to go over it with you, answer any questions, and so that you feel confident using this tool. It's very powerful. As I said in the beginning, many years went into developing of this tool so that it provides sound designs, really reliable designs, that they integrate all the capacity of our previous tools that are available in the customer portal, in terms of performance, in terms of SOTE, head loss, etc. So it's a really powerful tool. Again, not meant to replace our technical assistance, but just as a one more tool to invite you, or to empower you in your calculations. Let's see, do we have questions?
And one more thing I need to tell that
Sure.
the sort values and head loss values for the diffusers based on our test data, having result data from past 20 years, having different
Yes.
experience and different plant information. So whatever we are having information is genuine and correct, that sort values and head loss. So here you don't need to go again to check about head loss about at the top of droplet. How many conditions you have, the top of droplet values also change based on the diffuser airflow and the densities. Thank you.
Yes. Thank you, Nim. Yes, absolutely. The SOT results are based on independent tests that we have conducted, so they're reliable. Also, for the blower sizing, the information that it provides is accurate, and it accounts for side conditions. So you can use that airflow and the discharge pressure to go to your blower manufacturer and size the blowers accordingly. So let's see. We have, let's see, thank you very much for joining. There's a couple of you that are having a little difficulties to get your credentials, so we will work with the IT team to work on that. Anything else? Let's see, I see a couple. There's a general question that says, what is the minimum and maximum level recommended during the design? Nim, if you want, you can answer this, but for each diffuser, you can see the curve where it falls in terms of airflow rate and head loss. So the idea is for the result to match within that parameter. You need to account for the turn down condition, like minimum airflow range for uniform distribution, as well as the maximum. So looking at the curve, Jen, and where it falls in terms of capacity, it's a good starting point. I don't know if you want, Nim, if you want to
Yes,
jump in
and
that.
also we kept a flexibility here, like sometimes total airflow based on the oxygen loadings will be less compared to tank dimensions. Then we kept to switch over that to blower sizing, airflow through the minimum mixing, like to have uniform distribution, we always keep 0.1 to SCFM per square feet or
Mm-hmm.
2.2 meter cube per hour meter square. So out of which
For
will be the
mixing.
maximum it takes as a design consideration for total airflow, and it is the output for the blower sizing. And always it also alert that the design which falls in the minimum airflows and maximum airflows. If sometimes in some very rare cases like uh, it should be like total airflow with the oxygen loadings, also minimum mixing for uh, with 0.1 to SCFM per square feet will be less sometimes to operate the diffusers, because each diffuser have their own minimum airflow condition to operate or to release bubbles. For example, if you take 9-inch diffusers, it go as low as 0.45 SCFM or zero point 0.5 SCFM. Then the design take in a different way, like minimum diffuser quantity to maintain 5% diffuser density with uniform distribution. We need to have 5% density, the quantity, and the minimum airflow, which gives as a total airflow. That means it will be maximum of total airflow through oxygen loading versus minimum mixing airflow. Then it goes differ quantity into minimum airflow to supply for the tank.
Okay. Thank you, Nim.
Yeah.
Okay, we have questions if the presentation will be posted. Yes, all the webinars are going to be available on our website, and I believe that we also send an email, a follow-up email after the webinar with the link to the recording, so you can listen to it later and have it as a resource for other times. Says some other brands offer the high design flow per diffuser, 9-inch and 12-inch. We offer lower side. How to explain? Well, you can select based on OPEX or CAPEX, and also we have the 2mm slit option gives you a higher high airflow capacity diffuser. That's one of the questions. I think that is for now. We can answer any other questions that you might have offline. Feel free to send us an email, and we will go from there. We hope that you find this webinar useful, and we hope that you will integrate the design calculator as a valuable tool for selection and design of aeration systems, and that you continue having SSI as your partner for that. Thank you very much for joining us, and I think if unless anybody wants to add something or ask another question, I think that we can conclude the presentation. Thank you very much for joining us.
Thank you. Thank you, everyone. Thanks, Lina, for your help.
Thank you, Nim. Thanks, everyone. Have a wonderful day.
Thanks,
Take care.
Tom, answering so many questions over the client questions here. I'm seeing. Thanks, Kelsey.
Goodbye, everyone.
Thank you. Bye.